The Voyager mission was designed to take advantage of a rare geometric arrangement of the outer planets in the late 1970s and the 1980s, which allowed for a 4-planet tour, for a minimum of propellant and trip time. This layout of Jupiter, Saturn, Uranus, and Neptune, which occurs about every 175 years, allows a spacecraft on a particular flight path to swing from one planet to the next without the need for large onboard propulsion systems. The flyby of each planet bends the spacecraft's flight path and increases its velocity enough to deliver it to the next destination. Using this gravity assist technique, first demonstrated with NASA's Mariner 10 Venus and Mercury mission in 1973-74, the flight time to Neptune was reduced from 30 years to 12. While the 4-planet mission was known to be possible, it was deemed to be too expensive to build a spacecraft that could go the distance, carry the instruments needed and last long enough to accomplish such a long mission. Thus, the Voyagers were funded to conduct intensive flyby studies of Jupiter and Saturn only. More than 10,000 trajectories were studied before choosing the two that would allow close flybys of Jupiter and its large moon Io, and Saturn and its large moon Titan. The chosen flight path for Voyager 2 also preserved the option to continue on to Uranus and Neptune. From the NASA Kennedy Space Center at Cape Canaveral, Florida, Voyager 2 was launched first, on August 20, 1977. Voyager 1 was launched on a faster, shorter trajectory on September 5, 1977. Both spacecraft were delivered to space aboard Titan Centaur expendable rockets. The prime Voyager mission to Jupiter and Saturn brought Voyager 1 to Jupiter on March 5, 1979. And Saturn on November 12, 1980, followed by Voyager 2 to Jupiter on July 9, 1979, and Saturn on August 25, 1981. Voyager 1's trajectory, designed to send the spacecraft closely past the large moon Titan and behind Saturn's rings, bent the spacecraft's path inexorably northward out of the ecliptic plane, the plane in which most of the planets orbit the Sun. Voyager 2 was aimed to fly by Saturn at a point that would automatically send the spacecraft in the direction of Uranus. After Voyager 2's successful Saturn encounter, it was shown that Voyager 2 would likely be able to fly onto Uranus with all instruments operating. NASA provided additional funding to continue operating the two spacecraft and authorized JPL to conduct a Uranus flyby. Subsequently, NASA also authorized the Neptune leg of the mission, which was renamed the Voyager Neptune Interstellar mission. Voyager 2 encountered Uranus on January 24, 1986, returning detailed photos and other data on the planet, its moons, magnetic field and dark rings. Voyager 1, meanwhile, continues to press outward, conducting studies of interplanetary space. Eventually, its instruments may be the first of any spacecraft to sense the heliopause, the boundary between the end of the Sun's magnetic influence and the beginning of interstellar space. Voyager 1 entered interstellar space on August 25, 2012. Following Voyager 2's closest approach to Neptune on August 25, 1989, the spacecraft flew southward, below the ecliptic plane and onto a course that will take it to interstellar space. Reflecting the Voyager's new transplanetary destinations, the project is now known as the Voyager Interstellar Mission. Voyager 1 is now leaving the solar system, rising above the ecliptic plane at an angle of about 35 degrees at a rate of about 520 million kilometers, or about 320 million miles a year. Voyager 2 is also headed out of the solar system, diving below the ecliptic plane at an angle of about 48 degrees and a rate of about 470 million kilometers, or about 290 million miles a year. Both spacecraft will continue to study ultraviolet sources among the stars, and the fields and particles instruments aboard the Voyagers will continue to search for the boundary between the Sun's influence in interstellar space. The Voyagers are expected to return valuable data for 2 or 3 more decades. Communications will be maintained until the Voyager's nuclear power sources can no longer supply enough electrical energy to power critical subsystems. The cost of the Voyager 1 and 2 missions, including launch, mission operations from launch, through the Neptune encounter and then the spacecraft's nuclear batteries, is $865 million. NASA budgeted an additional $30 million to fund the Voyager interstellar mission for 2 years following the Neptune encounter. Be sure to subscribe and press the notification bell to receive all future informative videos about our solar system.